Hi everyone, I am Sukran Karaosmanoglu from University of Hamburg, and today I will present the paper Born to Run, Program to Play, Mapping the Extended Reality Exergames Landscape. Maintaining a healthy, physically active lifestyle is challenging. And unfortunately, lacking physical activity is a rapidly increasing problem in our modern society. In fact, 81% of adolescents are currently insufficiently active. This has not only immediate consequences on fitness and mental health, but is also connected to many severe health issues, such as cardiovascular diseases. So we must find ways to encourage people to exercise more and more regularly. One promising solution is to use games as a motivational booster. So-called exergames combine enjoyable gameplay with demanding physical exercise to deliver engaging and beneficial experiences. And while traditional exergames have been around for quite some time now, attention has recently shifted to extended reality setups that could lift this genre to next level. Because XR exergames have some unique advantages, such as the inherently special interactions or the full control over player surroundings. This increased interest becomes apparent when we look at the publications on XR exergame research. Over 50% of the papers were published in the last 3 years alone. But unfortunately, while the research corpus is growing rapidly, we currently do not have a review or taxonomy that organizes the field. And this makes it difficult to understand the prior research and see open promising research directions. To assess current exergame contributions, we conducted a scoping review. First, we carefully decided on a search string with 23 keywords and extracted all matching papers from 3 digital libraries. After removing the duplicates, we had just over 1,000 papers. Then we screened the title and abstracts, later the full text to check if the publications met our inclusion criteria. In the end, 186 papers remained. From those, we retrieved all relevant data with an extraction form. This information covered 158 conducted studies and 195 XR exergames. In the end, we delivered 4 main contributions. We analyzed the data quantitatively to find patterns in the study designs. Next, we constructed a taxonomy that captures the design space of current exergames. And we provided a set of guidelines to improve the reporting standards of this field. Also, we discussed 9 promising research directions. For example, one finding of our frequency reporting was an imbalance in how studies on exergames were conducted. While the average participant age for our evaluated studies ranged from under 10 to over 90, we saw that most studies focused primarily on younger adults. In fact, 48 studies reported an average age between 20 and 30. This shows a massive bias in the targeted population of exergame studies. For 65 studies, papers reported the sample culture. And while we had studies from 16 different countries in our corpus, over 70% of them were conducted in Europe and North America. In total, we went through 180 user studies, which had on average 24.6 participants and covered a broad range from single participant case studies to large evaluations, reaching 250 players. However, almost 80% of those studies let players experience the exergames only once. Lastly, we also found a wide variety of used XR devices, ranging from popular models such as Meta's Quest to more niche, outdated hardware like HoloLens or Gear VR. Interestingly, the majority of research focused on PC-bound VR headsets, mainly using the HTC Vive, Oculus Rift, and Valve Index. Next, we created a taxonomy of XR exergames that guides design, implementation, and research of future XR exergames. To do so, we first decided on meta characteristics of the taxonomy. We were inspired by the people, activities, context, technologies framework of HCI field that serve as a guide for creating interactive systems using a human-centered design perspective. Our adapted meta-characteristics were goals, people, exercises, design, and technologies. To create a taxonomy, we considered all the featured Exergames as a data unit. Our coding approach was hybrid, so we used both deductive and inductive codes. Our resulting taxonomy consists of 5 dimensions. The goals dimension captures the main goal of the Exergames. Every game intervention has a goal, be it a physical training, medical focused training, or a cognitive training. Also, Exergames often tailor to specific age groups and health conditions, like physical disorders. Of course, the core elements of each application are the featured exercises. While our text goes into more detail regarding the specific movements, our taxonomy mainly distinguishes between the involved body parts and the positioning which users can play the exergame. The design dimension covers the various choices of game design. For example, which kind of in-game tasks are used? Is it single or multiplayer? And which theme does the game have? Also, exergames often feature some sort of adaptation, such as physiological and performance-based. And lastly, the use technology. The category includes the use displays. Is it VR or AR? The type of setup. In the past, most of the VR applications needed a PC, while modern headsets are often mobile. And some exergames also require support hardware, like exercise machines, safety harnesses, or physiological sensors. But how to use this taxonomy? With our taxonomy, our goal is to create a more standardized and systematic approach to exergame design, research, and communication in the field. With a building block approach, researchers can explore how exergame features can effectively incentivize individuals. For example, to promote social interaction. Some of the challenges we encountered during our data collection and coding process came from differences in how exergames and studies were reported in the papers. In particular, many papers miss the details that are necessary to reproduce the findings. For example, 35% of papers do not report their exergames goal. Similarly, 74% of papers do not mention their target audience. The level of descriptions of the movements performed in the exergames was also different. For example, some papers reported using dodging movements, but which movements lead players to dodge the obstacles were not clear. Also, in some instances, it was unclear which displays were used to present the exergames. So we had to consult additional resources like figures or supplementary materials. To address these issues, we provided with a set of guiding questions that should help researchers, developers, and designers report all aspects of their games transparently. Lastly, we also discussed 9 future directions. Almost all of identified goals represent serious purposes. But do exergames need to have serious goals? Rare examples also show the promise of relying on players' inherent motivation. But current decision of exergame design seems on enforcing physical activity. Only very few studies examined the differences between user groups. This limited research attention is problematic, since users with different abilities or physiologies play differently and prefer different tasks. This also brings up the question what to consider as exergames. Our taxonomy answers this question with "it depends." We saw that some games were considered as exergames despite the little physical activity. We believe that physical effort required for a digital game depends highly on the user group, and researchers and developers should pay attention to this aspect. Most papers with an age target focused on older adults. However, However, only 24% of studies had a sample with an average age above 40. This discrepancy between the target user group and evaluation is problematic. Simply, the effectiveness of the exergame intervention and validity of the measured player experience remains unclear. Overall, we see only limited exploration of different age groups, and we cannot assume that all exergames work for any age group. In contrast, we could even potentially harm people while driving for the good. When designing exergames, designers should consider people's cultural background because sociocultural factors influence how we use and accept technology. However, in exergame research, European and North American studies accounted for 72%. This raises doubts regarding the generalizability and relevance of exergame studies to non-Western cultures and calls for future work. Also, social interaction and multiplayer support received little attention. However, social settings are a critical factor in providing motivation to exercise, for example in sports. We assume this effect can apply to exergames too, and therefore we encourage further research in this area. Next, the games in our corpus were split almost equally between seated and standing gameplay. This spread is beneficial because both roles have crucial use cases. The standing setting can enable full body exercises to combat our current lifestyle of sitting too much. However, many people may be unable to do this. To be inclusive, it is best to support both seated and standing positions. However, only 6% of our games supported this option. Of course, supporting both options might be difficult since most games must be designed from the ground up with this goal in mind. Hence, we advise developers to consider these early in their design process. Interestingly, only 5% of the analyzed games support AR HMDs. Similarly, cave-based exergames are rare. We attribute this to unavailability of AR HMDs or the high retail price and immense space requirements of caves. Also, the long-term effects of exergames are poorly studied. Only 9 studies evaluated effects over more than 2 play sessions. Thus, the practicality of such games beyond gameplay novelty remains unknown, hence we recommend further research. Lastly, we believe that many of the guiding questions and taxonomy dimensions can be easily applied to other exergames or applications. Also, we speculate that bias in the representation of certain age groups may be applicable to broaden HCI research, but further research is needed to inform this. Thank you for listening to this talk. Please refer to the paper for more details and contact me or my co-authors with any questions.